For question number 3, the variation in extension x of the force F acting on the spring is shown in figure 3.1. So this is the force against extension graph. So the spring of unstretched length 0.40 has one end attached to the fixed point as shown in figure 3.2. So the unstretched length spring has initial length, that is LO, as 0.40. Then a block of weight 2.5 Newton is attached to the spring. The block is then released and begins to move downwards. So now the block of weight 2.5 Newton is attached to the spring, and now the spring moves downward, or it extends, and this is the final length. At one instant, as the block is continuing to move downwards, the spring has a length of 0.72 meter as shown in figure 3.3. So 0.72 meter as the final length. Assume that the air resistance and the mass of the spring are both negligible. So air resistance and the mass of the spring is negligible. Now for part A, further change in the length of the spring from 0.40 to 0.72, use figure 3.1 to show that the increase in elastic potential energy of the spring is 0.64 joules. 0.64 joules. So what is elastic potential energy? So we know that elastic potential energy is equal to half Fx or half kx square, where k is the spring constant, x is the extension. Extension is final length minus initial length. So x is the extension and F is the force. So we need to use figure 3.1. So this is figure 3.2 and 3.3, and we need to use figure 3.1 to find the force and the extension. So we need to use figure 3.1 to calculate the increase in elastic potential energy. So from figure 3.1 so here it is mentioned that from increase in length from 0.40 to 0.72 meter. So what is the increase in length of the extension? So the extension is 0.72 minus 0.40. So the extension that we get is 0.32 meter. It is 0.32 meter. And here since for figure 3.1, it is a force against extension graph. So we need to get our extension in order to calculate the value of force. So the extension is 0.32. And for 0.32 extension, the force is 4 Newton. So the force that we get is 4 Newton for an extension of 0.32 meter. This is x, that is the extension, final length minus initial length. So elastic potential energy would be half Fx, that is half 4 into 0.72 minus 0.40, that means 0.32. So the elastic potential energy that we get is 0.64 joules to two significant figures as shown. You have to mention shown. Now we need to use figure 3.1, and if we let's suppose we use 3.2 or 3.3, and instead of just and if we just ignore this, then we can see that the weight is 2.5 Newton. That means the force would be 2.5 Newton. 2.5 Newton. So since we can see that the weight is 2.5 Newton, so we can consider the force as 2.5 Newton. But this would be wrong because we need to use figure 3.1. So from figure 3.1, we get the force as 4 Newton. So you have to remember that what is mentioned in the question, that which figure do you need to use. Calculate the decrease in gravitational potential energy of the block of weight 2.5 Newton. So now we can consider the weight or the force as 2.5 Newton. So the gravitational potential energy, that is GPE, is equal to mass into gravitational field strength into height. And so we have given the value of weight. For the weight that is 2.5 Newton, and we know that weight is equal to mass into gravitational field strength. So mass into gravitational field strength is equal to 2.5 Newton. So mass into gravitational field strength is equal to 2.5 Newton. And what is the height or the increasing height? So calculate the decreasing gravitational potential energy. So what is the decreasing height? So here we can see that initially, let's suppose this is the base level, and from this base level the initial height is, so this is not the height, the initial height is, okay, instead of considering this, what is the decreasing height? Initially our point is at this point, now it is at this point. So from this point to this point, what is the change in height? So the changing height, that is 0.72 minus 0.40, we get a change in height, that is 0.32 meter. So this difference in height is 0.32 meter. 0.32 meter, that is 0.72 minus 0.40 is this difference in height or the decreasing height. Since the height decreases, so the gravitational potential energy also decreases. So the decreasing height is 0.32 meter. So the height is 0.32 meter. After multiplying, we get a decreasing gravitational potential energy as 0.8 to one significant figure. This answer is to one significant figure, but for physics, we need to give maximum amount of answers. That means almost all the answers to two significant figures. So we need to convert this to two significant figure, that is approximately 0.80 to two significant figure, that is 1, 2. And if you write this answer, then this might be wrong. So it is better to write our answer as two significant figure as given. So use your information in A1 and your answer in A2 to determine for the instant when the length of the spring is 0.72 meter, the kinetic energy of the block. So from A1 and A2, so we need to use both the answers. So from A1, there is an increase in elastic potential energy, and from A2, decrease in gravitational potential energy. So initially, at the topmost point, because the base of the spring is at this point, so we consider this point as the topmost point, and now this is the final point. So if we consider this point, since it is at the greatest height or the topmost height, so initially we have gravitational potential energy, GPE. So initially we have gravitational potential energy and no other energy, since it is an unstretched spring, and after the spring has extends, it has obviously elastic potential energy, that is elastic potential energy after the spring extends plus kinetic energy, that is EK. So initially we have gravitational potential energy, and this gravitational potential energy is changing to elastic potential energy plus kinetic energy. So initially we have gravitational potential energy, that is gravitational potential energy, and this gravitational potential energy is converted to kinetic energy and elastic potential energy, and elastic potential energy due to the extension of the spring. So the decreasing gravitational potential energy, that is 0.80, that is 0.80 is equal to the increasing kinetic energy, and we need to find the kinetic energy or the increasing kinetic energy, that is del EK plus the increasing elastic potential energy, that is 0.64. So increasing kinetic energy is equal to 0.80 minus 0.64, that is 0.16 to two significant figures. So this is the increasing kinetic energy. Then the speed of the block. So now we need to convert the speed of the block, and we can calculate this from kinetic energy. So kinetic energy, we know that kinetic energy is equal to half mv square. So we know the value of kinetic energy. We know that it is half. And what is the mass? So initially, we know that you have to remember that we need to use A1 and A2. So from A1 or A2, we know that the weight is 2.5 Newton. So the weight is 2.5 Newton. So what is the mass? Mass into gravitational friction is equal to 2.5 Newton. This is 2.5. So mass is equal to 2.5 by gravitational friction, that is 9.81. So 2.5 by 9.81 into v square. And we need to find this v or the speed. So after calculating, we get the speed as 1.1 meter per second. That is two significant figures.